This is Lauren Ross. I am the manager of engineering research, and we're going to be talking about this DCA6 in the 2015 version of it. So here's the copyright materials for the presentation, and then information about being credited with AIA so that you can get your credits there. Here's the course description. Hopefully you've already read that before you signed up for it, this presentation. Okay, so here's the objectives, and then in my opinion, the first one is the most important one, because we're going to be talking about what actually has changed in DCA6 from the last two editions. Specifically, we're talking about the 2015, the one that's based on the 2015 IRC, but we're throwing in the 2012 because there was quite a few more changes between the 09 and 2012 than there was between the 12 and the 15. Also, I know a lot of jurisdictions skipped over the 12 and went from the 9 to the 15. So just so we're all at the kind of the same foundation, we're going to be talking about the 2012 as well. Okay. And then this is the outline, kind of what we're going to do. We're going to talk about DCA6 history, again, kind of saying how we got to where we're at now. We're going to talk about the changes, and then we're going to hit up the commentary and the appendices. Okay, so this is the first poll question. We do this question really to know who our audience is, so I can make the appropriate comments.
All right, this one's exceptionally easy. Everybody just put in what your profession is, and I'm going to give you about 30 seconds. So I'd love to see 100% vote. Usually we get about 85% of you vote. So, and I've got 87 right now, so that's awesome. All right, and it's 30 seconds. So let me share that. So 56% engineers, 30% building code officials, 9% other, 4% architects, and no fire code officials with us today. Okay. Welcome to you all. We're happy you're here.
Yeah, thank you. So yeah, I'll try to make sure I cover some of the engineering for the majority of the audience here. So first off, DCA6 is a free download. This is a link to it, but the easiest way to get it is either right in the chat box. Brian has sent out a link to it, or if you go to our website, www.awc.org, and the right-hand side there has some quick links, and one of those is the deck guide. That's the easiest way to get it. So the history of DCA6 kind of starts from just noting how many problems there were with decks. It seems like still every week I get an email notification saying that a deck collapsed and so many people were hurt, or this or that. And most of them are caused because of the exact same thing that you see in this picture right here, where the ledger of the deck basically fell away from the house. Now, that was a big issue, so research was started to do it. Codes were wanting to address it, and AWC was tasked with coming up with a document to make decks safer. So it wrote DCA6. First thing we did was we looked out at what was already existing, and Fairfax County of Virginia already had a very nice deck guide, and so we borrowed heavily from it and tried to make it on a more national scale. So we include like Western species of lumbers like Hem-fir, Douglas fir larch. We also reached out to ICC because we wanted to make sure that they were a cooperator in making this new document. But we also had other cooperators too. APA, National Association of Home Builders, of course, are ones that come to mind. And we also had NADRA, North American Deck and Railing Association, and a couple universities that were doing some of the research about it. So the code basis of DCA6 in this edition is based on the 2015 IRC. So all the decks we're talking about for DCA6 are limited to the same type of thing, the residential IRC world. However, there are instances when DCA6 goes beyond the IRC, and there's also good information in DCA6 if you are going to be designing like a commercial deck or something like that, that I at least would have found helpful when I was designing, to say, oh, okay, so this is kind of the assumptions they made, I should do the same thing for mine. So DCA6 does not cover residential or high-rise residential even, but it does have some information in it, and that will be useful for you. And the one information that is beyond the IRC is just good practices for it, good recommendations for it. So obviously the IRC or whatever your local code is going to govern, but the manufacturers and things, we have a bunch of good recommendations in there, and we'll describe them as we go on. So this is the first polling question, and we just talked about it, so hopefully everyone will get it right.
Alrighty, here we go. So DCA6 contains certain good practice recommendations in addition to IRC requirements. True or false? So, all right, 70% have voted. Alrighty, 80% have voted in 20 seconds, so awesome. Let us go ahead and close, and we will share. All right, so 100%, I think, got this one right, folks.
Yeah, sure did, exactly. It's there are areas that DCA6 kind of goes beyond the IRC, as I was saying, and those are just good practice. Okay, so here's the top 10 type of changes for DCA6 12 and 15, and again, we're including the 2012 version in there because some jurisdictions have jumped over that. So the first one and probably the biggest one is that DCA6 requires hold down tension devices on all decks. So in other words, for lateral support, you always have to be connected to the house in some way, shape or another. There's no such thing as a truly freestanding deck per DCA6. Aspect ratio, that's just how far the deck projects away from the house versus its length or width. And another one, that post heights are based on tabulated values. In other words, how long your beams and joists are versus just saying any 6x6 can handle all situations. 2x6 joists were added for small, so that if you have like a small deck that's like a landing or something along those, you don't necessarily need to use a 2x8, you can use a 2x6. We added some I-joist details for that hold down tension device. The overhang table or cantilever table for the joist is changed significantly. The beam table we added some glue laminated timbers because I know at least like in Colorado in places they use that. Some more footing options were added, and knee braces. What was required for knee braces was changed a little bit. So let's start from the top going down. So this is table 1, and it's talking about lumber and what's required of the lumber. And these are showing preservative treated, and it's species that are typically treated and what they're treated for, so above ground versus ground contact. Now, most of the time when you go into a big box store and you buy your posts or whatever it may be, the chances are, and it's probably going to be treated for ground contact. The label should specifically say, just because you're only going to be able to find ground contact because the supplier doesn't want to have both and make it so it's hard and difficult for the person buying it. Now, obviously, you probably can get just above ground treatment if you go looking, but most big box stores only take ground contact, and you can obviously use ground contact for above ground as well. So it's a nice conservative thing. Okay, then decking. we go down from, and it follows the ALSC policy, basically. So we're, instead of going from, we're talking about all lumber, now we're just going down to decking, and we're going to be following the ALSC policy. There was one change from into the 2012 DCA6, and that's the number of joists that are required for bearing. It used to be 2 joists. We switched it over to 3 just because you get a lot of creep and sag if there's only 2 supports. That third, having a continuous span, 2 spans on it, makes it so it's a little resistant to do that. And obviously, a substitution approved by the building official. Here's we're going down one step further and doing joists. So here's one of the 3 figures we have that kind of explains joists. And you'll notice a couple of things here. First off, you'll see that blocking and overhang joists only. So previously, I'm not sure if there was, I don't think the DCA6 required necessarily that blocking, but it is there for the 12. And then the other thing you'll notice, that for all the engineers out there, that our definition of span is a little different. If you're familiar with the National Design Specification for Wood Construction, or NDS, you'll know what the definition is usually like. Center point of bearing is center point of bearing, or something along those lines. But this is kind of an IRC world, so we made it so it's a clear span. So it's inside face support to inside face. So that was to be consistent with our other span tables that are commonly used. IRC doesn't really necessarily define well what its span is, but because we wanted this to be friendly for weekend warriors and everyone else, we went with the clear span rating for that. And so to adjust from engineered span, which we were actually calculating per the NDS, to clear span, we basically subtracted 3 inches, or half of each bearing. So if you look at the IRC versus DCA6, you'll notice that there is about a 3-inch difference between the two. Which brings us to our next polling question.
Absolutely. So DCA6 defines span as clear span, inside face to inside face of supports, engineering span, center to center of bearing, outside span, outside face to outside face of supports, or none of the above. All right, we've got about almost, 80% and 30 seconds. So I'm going to close and then go ahead and share. So 90% say clear span, 6% engineering, and 2% for each of the others. So Lauren, I'm going to let you go ahead and explain.
So, yep, that's exactly right. 90% of you got it right. It's that clear span, inside face of support to inside face, because that's really the easiest for the contractor or the dad that's trying to build it in the weekend or whatever it is to measure. Okay, so now this is an example of the joist table in DCA6. Now there's 3 aspects that were new to the 2012. First is that southern pine. If those are familiar, the southern pine design values recently changed. If you're not aware of that, you really need to go to our website and check it out, and it talks about that. And the last few versions of the IRC have had that in it, and this right here, the DCA6 2012, is when it started getting really, it was just integrated, those new design values were integrated into the document. Before, the previous version had to have an amendment to cover those. The second thing is that 2x6, and again, that's for like landings or very small decks that you don't really need a 2x8. And there you'll see that there's a footnote 6, and we'll talk about that footnote 6 a little bit more, but it's basically for guard attachments that you shouldn't be using 2x6s, but rather 2x8s. And then the third thing is that far right-hand side that says allowable overhang, and that is probably the biggest change to this table. So it used to be that the left half of the table would say allowable span without overhangs, and then the right half of the table would be allowable span with overhangs. And so if you had overhangs, you had to go to the right, and you were allowed up to a quarter of that span. And now it's just saying, look, whether you have overhangs or not, you're allowed this span, and then you can go up to this allowable overhang, and it's 1/4 the actual span, or what this L sub O table says. Now, there's a couple of things I want to make sure I explain about this. One is that there's kind of what these loadings on these overhangs are. Obviously, you have the 40 PSF live load and 10 PSF dead load, but there's also, and it's not simultaneous, but there's also a 220-pound load at the end of the overhang when you have an overhang that we check, and that oftentimes makes it so it's a deflection controlled condition. Now, one of the biggest questions I get from this table is that it looks backwards. Like if you look at the 2x6 and you look at the allowable overhang, the 12 inches on center allows 1 foot, and then the 16 is 1 inch larger, and then the 24 is 3 inches larger than the 12 inches on center. And that's counterintuitive. And the reason for that is if you look over at the allowable span, the allowable span is significantly larger for the 12 inches on center versus the 16 and 24. And the further out those supports are, in other words, the larger the span is, the less stiff it is to resist deflection. And so when you have a 7-foot, 7-inch main span with 24 inches on center, you're actually allowed a little bit of overhang. But overall, if you use 12 inches on center, you're gonna be allowed a much larger deck. Now, this style of table was new to the 2012 DCA6, but it wasn't until the 2018 IRC that this new format came into being for it. So it's kind of a circular pattern a lot with DCA6. The code will develop this way, and then DCA6 will change to match the code, and then the code will say, oh, we liked how that was, and then it'll change to match DCA6. So it's kind of going a circular method. But this in particular was brought in the 2018. So if you look at the 2015, it's not going to look like this. And DCA6 is actually going to be a little more generous with their spans, consequently. We also max out the spans at 18 feet just to make sure that our footing sizes are reasonable and you don't end up with such a huge footing that no one wants to dig it. Yeah, so this new table, I want to throw this out there first before I move on, is this new format table was created by a user's request. So if you have, and we're going to be trying to start the 2018 here soon, and if you have any ideas how to make an improvement on the document, go onto our website and send us an email saying, hey, look, you guys should cover this or that, because there was a significant amount of changes in the IRC and the deck section between the 15 and 18. So we're going to have to do quite a bit of work for the 2018 anyway. And so we just want to make it as best we can. Okay, so a resource that you can use for doing joists, if you don't have an overhang, is the AWC calculator. So AWC has several calculators that I wish I had known about when I was designing. This is one of them, and it can do uniform lows and it can't do overhangs, but it can tell you about if you want to control the deflection and if you're using wet service, which should be doing probably for decks, and if you're in size lumber, which are little kind of tick marks inside or at the sides of the wood to make it so that the pressure treatment can seep in. Southern yellow pine isn't needed for that, but Douglas fir, hem-fir, those type will. And this will spit out a joist span of how how far you can go and things if you're not doing any cantilevers or overhangs. So as I said, one of the biggest issues and failures of decks is this ledger attachment. So this is a tested connection. So, and by that what I mean is if you tried to run the numbers on this per the NDS, you would actually have a hard time, mostly because you just don't have enough thickness in the members to actually, per the NDS requirements, connection requirements. So this is a tested application. They mocked it up in the lab and they tested it to say, okay, well, this is the type of spacing and things we need for these lag bolts or bolts in general to make it work. So when using DCA6, you don't have to take the wet service factor, for example, because it's a tested, it already accounts for it. But if you're trying to do design, you're going to need to do that. So moving on, DCA6 has a very similar image detail than that the IRC does, but this is one that's a little different from the IRC, and that is we have details on how to connect it to like existing concrete or solid masonry. And one of the important notes that was changed in the 2012 is right there in red. It says blocks filled with grout or concrete at anchor locations for new construction. What we didn't want is just CMU masonry to be there, and then you add this 1/2-inch diameter connection into it, and it's only really grabbing onto that CMU wall, so not that much. So we wanted it to have a good grip, and so we basically said, look, we don't want homeowners or whomever drilling a hole into the CMU and trying to fill it in with grout and then not sure how well they did or not. So we're limiting this to basically new construction situations. And you've got that 1/2-inch diameter approved expansion epoxy, basically a mechanical connection of some way, shape, or form. So moving down, we've talked about the joist and the ledger that supports them on one side, and then we're going to talk about this beam that supports them on the other. So the beams, this is a typical figure of how our beams work. This changed slightly with the 2015 from the 12 to the 15, and it's actually that where it says right there in the middle, it says beam splice if needed at interior post locations. That if needed wasn't there, so it almost made it sound like you had to have a beam splice at interior post locations, but that was never the intent. It's only if you can't get a piece of lumber long enough for it. And a very common, and it's true for both the IRC, if you're looking at the beam tables, and also ours, is that we say joists cannot attach from opposite sides of the same beam. Basically what that means is it's the assumption in the tables is that you have a full span and then you might have an overhang or you might not. But what we don't want this beam supporting is a full span and then another full span. So you have a full span on both sides, because the table doesn't assume that much of tributary area. So this is the next polling question.
Yes, indeed. So beam splices can only occur at interior post locations. True or false?
Yeah, and this is obviously in context of just DCA6.
All right, so about 70% have voted in 20 seconds. So just a little bit longer. All right, it's been about 30 seconds. I'll go ahead and close. All right, so 86% say true, 14% say false. And back to you, Lauren.
So for DCA6, that is true. Now, if you're engineering, you can make it so that that splice occurs at an inflection point or whatever you need to do. But for DCA6, we wanted it to be simple and easy to use, which meant that it could only happen over the interior posts. We just weren't sure about the understanding of the user to make sure that it would happen at the right location. Other than that, okay. And then here's the beam table itself, and it shows the glue laminated timber beams, again with a single span of joists, with or without overhangs on one side. And we changed that language in the 2015. This is showing the 2015 new language, just to make sure that that's clearer. Now, one of the questions that I often get about glulam beams, if you're not familiar with them, is the difference between balanced and unbalanced. So glulam beams are basically just dimension lumber stacked and glued it together and flatwise. And the worst stresses, the tension and compression stresses for a beam are on the top and bottom. And so you can optimize your wood by making it so that the best type of wood is in that highly stressed area. Now, balanced means that it's the same strength of wood in the tension and compression side. Unbalanced means you've got it stronger in one side. So oftentimes if you go out on the job site and you look at a glulam beam and it has an arrow and it says pointing up or down or whatever direction it says, then it better be installed that direction. Otherwise, you've got problems. Balanced is often used for if you have like it's going over two full spans, so it has like a post in the center, and that's because it's the direction of tension and compression is going to switch between the two, so it needs to be balanced for that. Oh, and again, we're actually limiting these spans to 18 feet again for the footer size. Okay, so the beam to the post. We encourage notching. The DCA6 says you should notch it just because we want bearing, especially for wet service conditions. You can imagine that those bolts just don't have much capacity, and we kind of want a belts and suspenders type of system where it's a direct bearing and it's good, makes good contact. This figure changed in the 2012 to give a little bit more description. Includes the maximum and minimum edge distances and things like that, so that it's more properly attached. And that's for 2x beams or 3x or 4x, so that you can notch it in. If you do a 3-ply beam, you're probably going to go over a 6x6 in size. You're going to be cutting too much meat out of that 6x6. So we recommend a post cap in that situation. Okay, so here's the footings. Again, we added 2 footings. One's kind of like a sonotube type situation, and the other one is this embedded post, which is the far right, that's actually from the post frame industry. It's an adaptation from that, so that you end up with a bit of moment capacity. The post can actually resist some bending. We require connections on all of our posts so that it can have as much lateral strength as it can be, because people run into it with mowers or whatever it is. So you want to make sure your post isn't sliding off. But the far right one in particular will add stiffness to your deck. We recommend gravel at the bottom instead of like a poured concrete slab or something like that, just so that when you end up pouring those sides, you don't make it so there's a water trap. There's kind of a bucket or a well for the water just to sit and eat at the post. So our requirements for DCA6 is it has to be 12 inches or frost line, and we assume the worst soil 1500 PSF capacity, just so that everything's always conservative. And that's a good assumption if you just don't know what's going on with the soils. So here's our post and footing size table. you'll notice on the left-hand side, it says beam span, joist span, and then it has the different, for the post, it has the different species, and in this individual cells, it says how far or how high that species can go. Previously, it was just it would say like 6x6 can go up to 14 feet, and that's how it is in the IRC. One of the biggest differences is that we require knee braces to add stiffness to the deck, but those knee braces can put load into the posts and cause them to do bending. So instead of pure axial load, you've got a bending, compression and bending combination. And so we didn't want to say, like in this case, it would have been 6x6s can only go 8 feet per the ponderosa and red pine. We split them out by different species so that you can see the differences between them. Another difference between the IRC and DCA6 is the aspect ratio. So what we do is we require the width or the length of the deck parallel to the house be equal to or greater than the length, which is the projection of the deck away from the house. And this actually has to do with diaphragm stiffness and capacity. For the engineers out there, you kind of actually imagine this as a shear wall that's been put horizontal. And so if your load's out there at the end, you have to bring it all the way back to the house, your shear back to the house. And if you've only got horizontal lumber, you can actually look in our special design provisions for wind and seismic and see that that's that's one of the weaker shear walls. It's not that great. Even if you did diagonal decking instead of the horizontal, you'd be better off. So it's just a matter of making sure that the load can get back to the house. So as part of the lateral systems, the 2015 IRC has this figure, and this figure's been in there for a while. It was part of the NEHRP or National Earthquake Prevention some report or something, anyway, but it's part of the NEHRP provisions. And they didn't really say whether this actually has capacity or not enough capacity. They just knew it was better than not having it. So they kind of threw this in, and consequently every IRC has just had it from that. We have the exact same method, except for ours is a little bit more detailed, so you can do like a slope so that condensation can get out. You can see that bottom one there. It's connected to an eye joist, so you can kind of know how to work with that. But the IRC specifically states that lateral load needs to be addressed in decks, but it doesn't say how much lateral load or what that lateral load really is. So when they give this option of, look, this satisfies that, we are taking it. We're saying, look, IRC says that's enough, then we're going to do that too. And there's still research going on lateral loads. This is another detail that you won't see in the IRC, and this is if the deck joists are perpendicular to the house joists. And it is a very ugly detail, as you can imagine, that would be very hard to install, but that's unfortunately where we're at the moment. So since we always require that lateral attachment to the house, we had to come up, and we coined DCA6, come up and coined this term non-ledger deck. So and that's different than a freestanding deck. A freestanding deck would mean that it's vertically independent. All the gravity loads are satisfied. The deck can support itself with gravity, and then also laterally. So any lateral forces the deck can take care of. Non-ledger decks is trying to say that it's vertically independent. The deck can handle its own gravity loads, but it relies on the house for the lateral, which is what we're calling out for those tension devices. So we coined that term. So there is no such thing in DCA6 as a freestanding deck. The best you can get is a non-ledger deck. New to the 2015 IRC is this detail right here. and it's a much more simpler and easier to install detail where you instead of doing 2 hold down tension devices at the end of the deck, you do 4 of these little, almost like L brackets that go into the top plate of the wall, and are a lot easier. You don't have to rip up the ceiling if it's an existing condition and all those situations. The problem is how this, if this was compatible or worked as well as the 2 heavy 1500 hold down tension devices isn't really known. It was never really shown. And for the engineers that or building officials that can kind of imagine this, this allows it at 4 of those locations evenly distributed. So if we go back to that shear wall example, it puts hold down tension devices kind of in the middle of the deck, not where the tension and compression would be if it were laterally rocking. So we were hesitant to do that. So we put it in the commentary saying, hey, look, this does exist, but go to your building official and work with him to see if that's a sufficient solution. So another thing that's different between the IRC and DCA6 is this, and we mentioned it already a little bit, and that's the knee braces. So knee braces stiffen up the deck, but they're not required per the IRC like they are for DCA6. And there are some changes in DCA6 between the 09 and the 12 that I want to talk about, and that is, one is that since we're always requiring those tension devices, there's no need to have the knee braces that would be perpendicular to the beam. The hold down devices are going to be stiffer and stronger, and so they would take the place of that. The second is, don't have those diagonal braces on the center posts. The reason for that is the center post is already taking more tributary area, more vertical load. We don't want to add bending moment into that post as well with the knee brace. So guards, this is another area where DCA6 is slightly different than the 2015 IRC. It used to be in the IRC, previous in 2012, 2009, all those, that the height of the guard, the 36 inches, needed to be measured from the walking surface. And that changed in the 2015. So now it's not from the walking surface. It used to be from the next adjacent surface, but it changed to the walking surface in the 2015. So like this picture right here, in the 2015, it would say that might be completely appropriate for height. For DCA6, no, we'd want that 36 inches from the elevation of the seating, because if you have kids like mine, they're going to easily climb up on that seating, and then they're going to climb right over the guard. And so it was felt that we should keep the 36 inches to adjacent level. Now, not all decks require guards. Only decks that are 30 inches above adjacent grade are going to need them, and it's going to be to the building official. I've heard it both ways as to whether if you have like a 20-inch deck but you do guards, as to whether they need to have the same level of safety as a guard that was 40 inches off the ground. Some of them view it as, look, there's an expectation of safety, so it has to meet the same standards. And then other people say, no, it's purely decorative, so you can put your plants on it or whatever it is. And so if you're doing guards one way or the other, I highly recommend talking to your building official. So the guard connection is a very debated topic, and it's also a tested connection. So the AWC IRC says, hey, you have to resist 200-pound concentrated load at the top of this. And if you go look at the IBC, it says you need to have, if you're doing a tested connection, you need to have a factor of safety of 2.5, which basically means you need to have a 500 pounds. And when your guardrail is 3 feet up off, and you only have a few inches of to resist how much that lever action is, it's a chunk of load. So it was tested. It was tested at Virginia Tech, and again there was some testing at Washington State. And what they did is they found a hold down tension device that had lots of capacity, and they kind of threw it on there. And it wasn't necessarily designed for that or even recommended for that purpose, but they were just trying to figure out what works, because a lot of the connections that they saw in the field were not working. Since that time, the hold down tension device manufacturers have come out with better options that are easier to install and would have the zinc or galvanized protection and all that. But it's still a very, very controversial issue. If you'll notice, this test is really only testing the post, and is only testing the post going away from the deck. So there's no such thing really, because they weren't thinking, technically the IBC and IRC say in any direction, but falling into the deck didn't make much sense, so they tested it outwards. There was a code proposal that tried to come up with commodity products and include that in the IRC, and that was proposed for the 2018, and it failed. And it failed, interestingly, kind of from both sides. Several engineers were saying, no, you're only doing it for 200 pounds in the outward direction. That's lessening the code requirements. And builders were saying, whoa, that's way too much hardware. We don't want to build to that standard, and that's way more than I build to, and I don't have problems. So it kind of got attacked from both sides, and did not work. But our details are tested and they work well. And we recommend that all guards have these situations for them, but you're not going to find that in the IRC. Okay, so going back to our outline, we've talked about DCA6 history, we've talked about the changes. Now we're going to get into the commentary and appendices. So the commentary specifically has background information, example calculations, and alternative provisions. So background information would be like, this is part of the joist overhang table, right? So this is a section of that, and these grade cells say, hey, look, these deflection limits are controlled by deflection limits. So if you weren't worried about deflection, you could actually go longer than that. And it's giving you that kind of background information seen underneath the hood, as it were, for it. Oh, and I forgot to mention the footnote 6. You can even see it right there. It has to do with the guards, right? So as I was talking about, that 3-foot height of the guards creates a large lever arm. Well, if you use a 2x6 joist, you just don't have enough space to resist that lever arm. So in the 2015, we hopefully made it clearer that if your joist is supporting a guard, it needs to be at least a 2x8. So that's what that footnote is. The commentary also provides example calculations. So we talked about earlier about how our beams are only supporting joists from one side, and how can we get around that for certain situations. So it kind of goes into this helpful guidance of saying, look, if you have it from both directions, what you can do is you can basically effectively double your joist length and then go into the table with that. So if your joists are 8 feet, have 8-foot span in it, you'd go into the table with a 16-foot, and that would be a conservative way to design your beam. And then commentary also has alternate provisions. For example, you can do a 4x4 post instead. If you're only a few inches off the ground, it would work well for you instead of and you could save some money by not having to buy a 6x6. There's also alternate provisions if you have higher soil bearing capacity. If you know that you have 3,000 PSF and you don't want to make your footings twice as large than necessary, then you can go about doing that, and we have tables for it. The appendixes are a little bit different. They're kind of, the first one is talking about where safety glazing is required for adjacent stairs. And then the appendix B is kind of the main document has, you know, it sizes the posts and footings based on how large your beam span and your joist span is. And for both of those tables, what you end up, what's being assumed is, you know, half, or is assuming half the main span plus, you know, the overhang, up to a quarter overhang. So if you don't have as large overhangs or whatever it may be, you might end up with a more optimized design if you go into Appendix B and say, okay, this is my tributary area, I'm gonna figure that out, and then I can say, okay, well, this is my post height based on that. And the same thing can be done for footing sizes, and again, with the different soil bearing capacities. Okay, so we're at the last poll question.
Yes, we are. Here we go. DCA6 commentary provides background information, example calculations, alternative provisions, or all of the above. All right, and we've got about 70% have voted. And just a few more seconds. All right, so we've got about 85% have voted. Let's see. So 95% say all of the above and just a smattering elsewhere. So let's go ahead. I believe that 95% are correct.
Yep, exactly. It's all above. Hopefully those examples that I provided kind of make that clear. Okay, now we're going into additional resources. The best one and most flexible one, of course, is the National Design Specification for Wood Construction. If you're an engineer, you're probably very familiar with this. It has column design, beam design, connection design, has the whole gamut of it, and it just makes it so that you can do ultimately whatever you want to do, and you have to use equations that some people might not like, but it allows most flexibility for that. One of the things that I did not understand very well when I first started designing with timber is the distinction between dimension lumber, beams and stringers, and posts and timbers, and that's important because they have different tables. Dimension lumber is basically anything 4x4 and less. Beams and stringers are larger than 4x4s, but then they have a considerable more depth because depth is more important for beams, and so they're graded as if they were beams being used in that situation. And posts and timbers are more squarish because for columns you need to have capacity in either direction the same. So that's the big difference for that. And then the supplement, you go in and it talks about using one of those three categories. You can go in and say, hey, look, so this is dimension lumber, and you can do it for redwood, and it gives all the design values that are needed for the equations. The supplement also would give adjustment factors, some of the adjustment factors. So like wet service, which is very important for decks, is an important thing to include, and the supplement will have that. Again, we have the span calculator, which does it, and then another calculator I think is actually probably the most practical for designers is there's a connection calculator. So if you have a unique situation, you can go to our website, awc.org, and go into the calculators, and there's a connection calculator, and it helps you figure out, hey, if I have a bolt in this situation and it's not covered in one of the tables in the NDS, but I don't want to go through the yield limit equations, it does it for you. So that's definitely one of the ones that I wish I had known when I was designing. The post heights, there's software you can get, like Woodworks, which this is a picture of, and There's also, of course, some stuff in the commentary. One thing I failed to mention was that 8x8s, if you wanted to use an 8x8 instead of a 6x6, you can always go up to the 14-foot height. And that's just what we cap our posts at. So you might have more capacity than that, but we didn't feel comfortable having decks be too high. So 8x8s are allowed, and that's in the commentary. Another document that you can use for column and beam design is this wood structural design data. And it's kind of a unique document in that you'll notice that it hasn't changed since it shows the 1986 edition with 1992 revisions. And the reason it doesn't really change is because all it's saying is, okay, you have a load of this on this beam and it's this long, then you need this strength of wood in order to work. And so it's keyed pretty much just to calculating stresses and not really the resistance side, which is why you need the NDS supplement for it. And both of those are free to view online at awc.org, and you get the supplement and you modify the values per the supplement's requirements, and you can put that into the charts and tables of the wood structural design data, and you can go from that if you don't want to do the NDS equations. Another thing that's important to recognize is the wood has very weak tension perpendicular to grain. NDS says that it basically should be avoided. And this often happens at notches, large diameter fasteners, hanging loads, and sometimes even just due to shrinkage. If your connection is not allowing the shrinkage, it'll part. The best way to think of wood is like a whole bunch of straws, and those are the cells, literally the cells of the wood, and they're going along the grain of the wood. And it's real easy to get those straws and make them go apart. It's a lot harder to compress them or pull them apart if going with their length. I was chopping some wood for a fire pit yesterday, and I was thinking about how the hatchet was going in, and it was literally just causing tension perpendicular to grain failures. So that's one of the reasons why a lot of decks failed, is either because the tension perpendicular to grain, because they didn't stagger those bolts, or they were using nails in it or something like that, and with the wet surface, it just did not have much withdrawal strength and it just fell. We have a bunch of e-courses online, including all the previous versions of deck presentations that we've done. So if you want to know more about specifically the 2012 or the original 09, then you can go online, and they're accredited, so you can get points for that. Another great resource is the Wood Design Focus, and they had a really good issue talking about lateral loads on decks. And it was interesting because they went through and they said, okay, well, they did the wind calculations for a deck, and it wasn't that much because, you know, decks don't really have much sail area, for lack of a better word. And then seismic decks are pretty dang light, so there wasn't really any seismic load. But then they did that, which shows that picture right there, which is people load. And how much can people create going side to side? And it's really funny when I talk to building officials about this, and I say, is that picture realistic? They'll be split. If many of them will say, no, that doesn't make any sense. No way would you have all those people moving back and forth. But if the building official is in a college town, they almost always say that, yep, I've seen those. That's exactly what happens. And drunk college students, instead of getting off the deck when it's swaying back and forth a foot, they say, hey, look, we're having fun, let's make it swing harder. And so it's people load that usually can control decks, and IRC doesn't really state what that is. There's still being research done. ASCE 7 still doesn't really know how to handle that yet. And unlike wind or seismic, you're absolutely always going to have occupancy load on decks, no matter where you're at in the country. So here's a couple more downloads. Again, the deck guide, and we have a one-pager if you're a building official and you'd like, we ask that you not directly link DCA6 to your website, but rather do the one-pager, because that way there's a link to it. So if we update DCA6 or whatever it is, we can it'll have a live update on that. And that's it for my presentation. If there's any questions, I'll have Lori come back on and answer them.
We've got a lot of questions. And it looks like more are rolling in as we speak. So we'll try to get to as many as we can. So the first question, some folks have asked about using wood plastic composites, some of those name brand decking products out there.
Yeah, so exactly. The wood plastic composites are allowed in the decking. That's the slide that says, hey, look, alternatives approved by building official. And so they're absolutely allowed. Just make sure you follow the manufacturer's recommendations. Mm-hmm. But one issue that is very common with those, and it can happen with wood, pure wood products too. If you're using like my sister had a very fancy deck with Ipe on it, and it's these hidden fasteners, which are basically look like T's, and there's a screw through the bottom of the T that connects to the joist, and then the two edges of the T go in and out of these grooves on the wood plastic or wood, and basically it just doesn't have any design, diaphragm action, because you're allowing it to be complete slop.
Right, those connections are crucial. Yep. We had some other questions about different loads on the deck, snow loads, hot tubs, other heavy loads. Can you talk about the loads that are in the scope of DCA6, and then what would not be included in the loading? Yes,
absolutely. So hot tubs, things like heavy loads, are outside the scope of DCA6. We assume a 40 PSF live load and a 10 PSF dead load. And that 10 PSF dead load is probably overestimating, but it definitely doesn't include hot tubs. And so we're limited in that scope. As far as snow, if you have it can go up to 40 PSF uniform snow load. And that's because we assume that you're not going to have 40 PSF of people and 40 PSF of snow on at the same time. You might have a person or two shoveling off the snow, but that's nowhere going to be near the load combination there.
Great. We've also had some questions. We talked about notching posts to accommodate beams and joists bearing on them. When you're dealing with treated lumber and you notch the post or you modify the ends in the field, can you talk about the requirements for treating those cut ends?
Yeah, so if you're, per the code and DCA6, you're supposed to actually treat those with a chemical treatment, copper naphthalate or something or other that's gonna protect that end there. It rarely happens though. I have actually yet to see it. In fact, I think I went to a local big box store trying to see if they even carried the stuff, and I didn't find it. But yeah.
So it does exist. Folks just might need to do a little work to find it.
More work. Yep.